Okay, now in this video we will discuss our question 5 for this prelim examination in Ibale for 2022 this year. So now lana question 5, it's a question on work, energy and power. Now what your block of mass m slides down a frictionless slope to point B. At point A, which is 0.7 meters above the ground, the speed of the block is 2 meters per second as shown in the diagram below. So let block here to move from A to B, and then eventually zoya point bani D. Right now, 5.1, but use the law of conservation of mechanical energy to calculate the speed of the block at point B. Now in the description below, uzothola ama link for amanyama questions for this question paper. Now, before we pendula the question, let's start off by defining what the law of conservation of mechanical energy is all about. Now, conservation of mechanical energy, law yakhona sistate ngale ndlela sithi the total amount of mechanical energy in a closed system in the absence of dissipative forces like our friction, air resistance, the mechanical energy remains constant whenever friction and air resistance is not present in your system. Now, lana between A and B, we can apply the law of conservation of mechanical energy. Why? Because there's no friction between A and B. Therefore, it means that the mechanical energy at A is equal to the mechanical energy at B, or in other words, the mechanical energy on the initial position is equal to the mechanical energy on the final position. So Tina scatter between A and B. Now take note, between B and D, energy is not conserved, right, because of the friction. Now lana again, this is a calculator in the speed of the block at point B. So we use the law of conservation of mechanical energy. So mechanical energy, basically it's the sum of kinetic energy and potential energy at any given point, right? So for A, it's kinetic energy at A plus potential energy at A is equal to the mechanical energy at B, which is kinetic plus potential, right? Now, the kinetic energy at A can be calculated as half m. Remember, abasiphangi mass, so faku m, and then at A we have a velocity of 2, so it's squared. Potential energy, it's mass times gravitational acceleration times the height, which is 0.7, equal to EKB, kinetic energy at B. And just going to calculate since asinayo velocity of the block at point B. So sizoyeka as VB squared, which is the speed of the block at B. Ile value sifuna ukuyicalculate. So kumele siyenze the subject of the formula. So the potential energy at B is 0, since point B is a point on the ground. I-reference yethu it's the ground. Therefore siyaqhubeka, 2 squared is 4 times a half is 2 m. Nayinto engisho engikhuluma ngayo, half times 2 squared equal to 2. This half times this 2 squared indicates our 2 plus 9.8 times 0.7 is equal to 6.86 m. The m is the mass of the block yet. So lana it's half mvb squared. 2 plus 6.86, it's 8.86 m, equal to 1/2 mvb squared. Multiply both sides by 2 so that we eliminate the fraction. So lana about 2 cancels 2, about mvb squared 2 times the 8.86 times 2 is equal to 17.72 m. Divide both sides by m. Cancel m cancel m. Ngifuna ukwenza VB the subject of the formula, so that's why ngidivide ngo-m ngale. Or ungathi na ufika kule step le so vele udivide ngo-half m, uvele udivide ngo-half m both sides, uzo end up somewhere la as well. Divided by uthatha the square root on both sides of the equation. VB is equal to the square root of 17.72 is 4.21 MV. So this is our answer for 5.1. Now on the next question, basipha a statement bathi the block moves from point B to D. Now le block naliqeda ukuyehla ifika la ku B, then ya move all the way up to point B on a rough horizontal surface. The kinetic frictional force between the block and the rough surface is 3 newtons. The block reaches point C with a momentum of 5.79 kilogram meter per second to the left. So remember, momentum is vector, so we need to specify direction. So it's to the left in the direction of motion, and the kinetic energy of 11.17 joules. So 5.2, calculate the speed of the block at point C. So at point C, ngakhohlwa basipha momentum, babuya basipha nani the kinetic energy. Sifuna calculate the speed. Do you have any idea, or the time ubhala this exam uyenze kanjani ke wena? Uyenze kanjani? Let me erase lana kuqala. Alright, now you take yami ke. This is my take. Yes, with 5.2 data. Let's take out the data. Remember, the block is from B to bani C. So we have a velocity at B. So calculate as 4.21 meters per second. Sifuna the VC, velocity at point C. I'm given a momentum which is 5.79 kilogram meter per second to the left, and then sine kinetic energy. Basipane kinetic energy 11.17 joules. Okay, the speed saka point C sizosicalculate kanjani ke? Well, this question is a little bit tricky nyana, ngoba iba tricky ngalendlela lekuthi bakupha the momentum, babuya bakuphe nani the kinetic energy, and you don't have mass. Mass awunayo la, right? So bakupha lama values lawa so that you can come up with or devise a way yokuthola i-value yakho without sort of like the need for using a mass in your calculations, right? So asize la, let's say momentum is calculated as mass times velocity, and then kinetic energy is calculated as half mass v squared, right? But ukhumbule ukuthi le momentum lena, it's the velocity at C. It's the velocity at C. So at point C, the momentum yam, it's equivalent to this. So the momentum at point C is calculated using the velocity at C. The kinetic energy bakupha yona at C. So the kinetic energy at C, we're calculating the speed of the block at point C. So labo velocities bethu kulama formulas lawa, they will be expressed in terms of VC, right? In terms of VC. So into esingayenza ke manje, uma uthatha ukubheka kahle la, you actually have a simultaneous equation in a way. So let's substitute for both equations. I do have E momentum, which is 5.79 equal to mvc. EK 11.17 equal to half mvc squared. Voila. So nani, this is a simultaneous equation. Uyayibona na? Awuyiboni? Okay, bheka ke mngana, bheka bangani bami, bhekani bangani bami. This is equation 2. So equation 1 yomsubstitute kuphi equation 2. Bheka ke manje, nangu equation 2. This is equation 2. Now equation 2 equal to a half mv squared. 11.17 equal to half m c lone. So it's v times vc. So it's mvc times mvc is equivalent to this. Why ngibhala so that uzokwazi ukubona lo mvc. So where there's mvc, you substitute that value. So it's 11.17 half mvc is 5.79 times vc. Voila. Then you divide by 5.79 half 5.79. They cancel lena, and then we calculate again. What's a calculator? So it's 11.17 divided by 1/2 times 5.79. Answer 3.858. 85 okay, so it's 858 meters per second equal to vc. So this is our final answer. Yeah. So hey, the paper yes. Okay, but it's fun. It was fun. Now the block comes to rest at point D, a distance x away from point C. Now ilokanje yethu block yethu beyislide from B to bani to C, then yathi nayifika ku D, then it came to rest. 5.3 state the work energy theorem in words. So normally angazi ukuthi uyayinotice lento le with ama question papers especially physics paper 1 where state, especially ku work energy and power, nabathi state work energy theorem. On the next question, in most cases kwamele vele usebenzise yona lo kanje i-work energy theorem, but in this case ku 5.4 bathi use energy principles only. So you can use any energy principle. It's not like you are restricted to using work energy theorem kuphela. So I was just pointing that out. Now 5.3 work energy theorem. Right now, work energy theorem in words. Okay, 5.3. So this is the theorem. Now so 5.4, use energy principles only to calculate the distance x. Now Lana, let's try using work energy theorem for 5.4. Zoti 5.4, the net work done is equal to the change in kinetic energy. the change in kinetic energy. A change in anything, it's final, EK final minus EK initial. A change in anything is final minus initial. So the work done, there's only one force at play, which is the frictional force, the 3 Newton. So the work is only done by frictional force. That's why block it when I figure out D and stop, because of you lose energy due to the frictional force, right? And it's acting in the opposite direction. Now see, I see again, man. So work done is calculated as force times delta x cos theta. So the final kinetic energy is 0. Why? Because of now figure with D, it comes to a stop. Initial kinetic energy, remember, sisuka from Gupi, from point C all the way up to Bani D, right? All the way to point Bani D. Sifuna calculator any distance from C to Bani D. So we use the speed as is calculator Gubani to C. So it's going to be half mv c squared, and then lana sina, okay, and then CT3 ish, but there's something in Warishayo, and then lana it's cos 180 degrees. Cos 180 degrees. Why? Because of the friction, it's in the opposite direction. So lana it's cos, okay, le thing Warishayo, maybe now we are supposed with the y m ala. Since asinayo m, it means this equation will have 2 unknowns, the x and the m. Relax man, relax, we got this. So we have about 3 times cos 180, just to show that it's minus 3. Since cos 180 it's negative, cos 180 it's negative times 3, it's negative 3 delta x 0 minus, it's 0 minus. So bega the kinetic energy at point C, I can calculate the potential energy if there's no m, but there's no need to calculate it, since pasipe the potential energy, where the kinetic energy at point C, which was 11.17 joules. So therefore it's minus 3. Instead of we calculate, you just substitute whatever was given statement. 11.17 delta x lana divide by negative 3 both sides. Delta x is equal to negative 11.17 divided by negative 3 equal to 3.723 meters. So this is our answer. This is our final answer for this question 5. I hope ukuthi nawe uthole an answer along these lines now. So yeah, thanks for watching, guys. In the description below there are links for amanyama video for this question paper. Like, subscribe. Now when new to this channel, please consider subscribing. Thanks for watching once again. Asibona nekule video ilandelayo, guys. Bye bye.